Okay, let's look at 7.3, number 11. So the question that Kiri asked about about 7.3, number 11 was, I don't see the critical value for 40. I have the correlation 0.986. Okay, so yeah, let's take a look. So 7.3, number 11. So it says, in a 1998 advertising campaign, Nabisco claimed that every 18-ounce bag of Chips Ahoy cookies contained at least 1,000 chocolate chips. Brad Warner and Jim Rutledge tried to verify the claim. We kind of looked at this example when we were discussing standard deviation. No, we were looking at Subway and Quiznos, weren't we? We weren't looking at Chips Ahoy, but anyway, chocolate chips, whatever. Okay, so they actually went through, opened up a bunch of Chips Ahoy bags and like broke the cookies or whatever and tried to count up however many chocolate chips there were, which is just crazy to me. Anyway, this is what they're coming up with. So yeah, I mean, it looks like each bag contains at least 1,000 chocolate chips, which is cool. Okay, so what are we supposed to do? It says draw a normal probability plot to determine if the data could have come from a normal distribution. So I'm gonna hopefully be able to load the data. Oh, come on. Is this even the same? Is this the same stuff? Let me see. In Excel, that's not what I want. Come on. Oh, there we go. Oh, okay, good. All right. So to do this in StatCrunch, we go to Graph and then QQ plot, and click on Add Correlation Statistic. Okay, that way it gets you this correlation statistic up here. So yeah, just like Kiri said, you should end up with a correlation statistic of 0.986. Now you have to compare that to a critical value from a table of critical values, which you could find in your book, or you could use the one that I posted in your notes. And yeah, it only goes up, the chart that I posted only goes up to 30. Let's take a look at that chart together. So the chart that I listed only goes up to 30, and that's a problem because this particular data set has 40 individuals in it, right? So if we take a look, so the largest number of individuals is 30, and we've got 40. And unfortunately, these critical values in this table, the critical values actually get larger the larger your sample size is. So it's kind of hard to say if we're going to beat the critical values since our table doesn't go all the way up to 40. Here's what I'm going to do. Let me look in the book and see if there's a more complete table. So I brought in my textbook. I'm looking in this appendix. So this is supposed to be table 6. Table 3, 4, 5, and table 6. No, it only goes up to 30 in your textbook too. Well, then the next best thing maybe we could do would be to just search. Just say critical values for normal probability plot. So critical values for the normal probability plot. Ooh. Okay, so here we go. These numbers are giving you different levels of confidence, which is something that we'll talk about later. To use the one that matches I think we would use this one to match with the chart that I gave you in your notes. So let's see, they go all the way up to 40. So for their critical value, now you only have to beat 0.9712, and we got a correlation statistic of 0.986. So there you go. We beat the critical value, although it was kind of hard to find. But yeah, but there's the critical value. Another way to kind of approach this is to just say, I mean, if you just look at this, right, these dots are all pretty darn close to this line, and the correlation is really pretty large. So I think it's pretty safe to say, even without like actually looking up a critical value, I think it's still pretty safe to say that there's that this variable is normally distributed. So so kind of, I guess, not a great question, just in the sense that the book didn't provide you with a table that really allows you to answer the question fully, but that's the idea. So it says draw a normal probability plot. We did that. Part B said determine the mean and standard deviation. Okay. So for that, you go to stat, summary stats, columns, right? Mean and standard deviation. Using that, draw a graph of the normal model, which you could also do in StatCrunch, right? Once you get the mean and standard deviation from this sample, you could draw, you could go to stat, calculators, normal, right? And then it'll draw that model for you once you put in the mean and standard deviation that you got in part B, which is kind of nice. Part D, using the normal model from part C, find the probability that an 18-ounce bag contains at least 1,000 chips. Okay. So you could do, we went through an example kind of like this, the Barbie's Bomber. Yeah, the Barbie's Bomber example, right? We did something very similar to that. So anyway, so I'm not going to take you through the rest of it, but if you look at 7.3, the Barbie's Bomber example, we went through kind of all of that stuff. And basically, yeah, I apologize. Your chart, it doesn't go all the way up to n equals 40. So it's hard to compare R to the correct critical value, but that's the idea. I'm kind of curious though, just to know what this looks like as a histogram. So I'm just going to graph a histogram just to make sure that it really is normally distributed. Oh, where should we start? I don't know. I'm just going to hit compute and let StatCrunch bin it for us. So it looks like it's binning by 50s. I mean, yeah, it's sort of normally distributed. I don't know, that's not perfect, but where do they start, this bar? They started at 1050. I'm gonna start at 1050. What if I go in widths of size 25? I wonder what that looks like. Oh, that looks worse. Maybe if I go in widths of size 100. That kind of almost looks skewed right. I don't know, but the correlation is undeniable, right? I mean, that's a really strong indication that the data is normally distributed. So so that's that one.